An elastomer is a polymer with viscoelasticity and very weak intermolecular forces, generally having low Young's modulus and high failure strain compared with other materials. The term, which is derived from elastic polymer, is often used interchangeably with the term rubber, although the latter is preferred when referring to vulcanisates. Each of the monomers which link to form the polymer is usually made of carbon, hydrogen, oxygen and/or silicon. Elastomers are amorphous polymers existing above their glass transition temperature, so that considerable segmental motion is possible. At ambient temperatures, rubbers are thus relatively soft and deformable. Their primary uses are for seals, adhesives and molded flexible parts. Application areas for different types of rubber are manifold and cover segments as diverse as tires, shoe soles as well as dampening and insulating elements. The importance rubbers have can be judged from the fact that global revenues are forecast to rise to $56 billion in 2020. Background. Elastomers are usually thermosets but may also be thermoplastic. The long polymer chains cross-link during curing, that is, vulcanizing. The molecular structure of elastomers can be imagined as a spaghetti and meatball structure, with the meatballs signifying cross-links. The elasticity is derived from the ability of the long chains to reconfigure themselves to distribute an applied stress. The covalent cross-linkages ensure that the elastomer will return to its original configuration when the stress is removed. As a result of this extreme flexibility, elastomers can reversibly extend from 5 to 700%, depending on the specific material. Without the cross-linkages or with short, uneasily reconfigured chains, the applied stress would result in a permanent deformation. Temperature effects are also present in the demonstrated elasticity of a polymer. Elastomers that have cooled to a glassy or crystalline phase will have less mobile chains, and consequentially less elasticity, than those manipulated at temperatures higher than the glass transition temperature of the polymer. It is also possible for a polymer to exhibit elasticity that is not due to covalent crosslinks, but instead for thermodynamic reasons. Examples of elastomers: unsaturated rubbers that can be cured by sulfur vulcanization, natural polyisoprene, Si1, 4-polyisoprene natural rubber and trans 1,4-polyisoprene gutta percha, synthetic polyisoprene, polybutadiene, chloropen rubber, polychloroprene, neoprene, Bapron etc. Butyl rubber, halogenated butyl rubbers. Styrene butadiene rubber, nitrile rubber, also called Barner-N rubbers, hydrogenated nitrile rubbers Thurbon and Zetpol. Unsaturated rubbers can also be cured by non-sulfur vulcanization if desired. Saturated rubbers that cannot be cured by sulfur vulcanization, EPM and EPDM rubber, epichlorohydrin rubber, polyacrylic rubber, silicone rubber, fluorosilicone rubber, fluoroelastomers Viton, Technaflon, Fluoral, Aflas and Diel, perfluoroelastomers Technaflon PFR, Corres, Chemras, Perlast, polyether block amides, chlorosulfonated polyethylene, ethylene vinyl acetate. The definitions are not authentic as the rubber which is classified in World Customs Organization books in Chapter 40, whereas the above definition stating all rubber and different polymers in same chapter which is classified in Chapter 39 of the World Customs Organization's Harmonized Commodity for Description and Coding System. One should go through all differentiation while editing between plastics and articles thereof and rubber and articles thereof. Various other types of elastomers: thermoplastic elastomers, the proteins resilin and elastin, polysulfide rubber, elastolefin, elastic fiber used in fabric production. References. External links: Common properties of rubber elastomers,